S1, discrete random variables, example 7. Before we look at example 7, let's just have a look at these results. You'll remember from earlier on in the course that if you had a coding such as ax plus b, you probably remember that multiplying by a does affect the standard deviation, but adding b doesn't. So if you had a standard deviation of x, you would multiply it by a, and that would give you the standard deviation of the coded data. You wouldn't add b. Now, if you remember, the variance is the square of the standard deviation. So rather than multiplying by a, you would multiply by a squared. So for example, if we had a coding of 3x plus 1, the standard deviation would be 3 times bigger than the original. But because you square the standard deviation to get the variance would actually be 9 times bigger, 3 squared. And that's what this result here is telling us. And this is the one to learn. So if you had a linear coding, we forget about the b, that doesn't affect the spread of the data. And instead of multiplying just by a, like you would do standard deviation, you multiply by a squared. So let's have a look at that on example 7. We've got to find the variance of 2x plus 3. Using that rule that we've just worked out, we know that it will be 2 squared times the variance of x. And we forget about the plus 3. In other words, it's 4 times the variance of x. So why don't you pause the video now and see if you can work out the variance of x. Okay, so the variance of x, if you remember, was sigma x squared px minus the mean squared. So before I start, I know I'm going to need the mean. So over here at the left-hand side, I'm just going to work out the mean very quickly. So that will be 10 times 0.1, 20 times 0.6, and 30 times 0.3. Okay, and if we add that up, the mean works out to be 22. So the variance will be 10 squared times 0.1, add 20 squared times 0.6, add 30 squared times 0.3, that's that first part done, and then take away the mean squared. Okay, type all that into your calculator, and I think when you do it all, it works out to be 36. So returning to the original question, the variance of the coded data would be 4 times the variance of x. That's 4 times 36. That would work out to be 144.